Okay, hello. Now the last lesson of this chapter, which is titration. So in this case, at this level, we're going to see two main types of titration: acid-based titration and redox titration. So again, this starts. It's acid-based titration. Acid-based titration. Initial reaction is a reaction between an acid and a base to give salt and water. So a typical example of a neutralization reaction, we're having sodium hydroxide, sodium hydroxide plus sulfuric acid. Now we have sodium sulfates, sodium sulfates. The equation of balance minus the equation. We check at the number of sodium atom. So sodium here is 2. Sodium here values 1 square. Multiply by 2. I multiply like 2, sodium is 2. Sodium is also 2, the other side. So the number of sodium atom. So hydrogen, adding 2 hydrogen here, plus 2 hydrogen is already apart. So we balance the equation completely to it. So we check if the equation balance. I need 2 sodium atom. Check the other sides, we need 2 sodium atom. So hydrogen, I need 2 times H right to H, so it's H2, that is 4H. The other side is 2 times 2, it is 4H. The number of sulfur atoms, 1 sulfur atom, 1 sulfur atom. Oxygen, let's take oxygen. Adding 2 oxygen, no sodium hydroxide, plus 4 oxygen, that is 6 oxygen. 4 oxygen plus 2, the 6 oxygen. That means the equation is balanced. At equivalence, the number of moles are the same. It means that at equivalence, the number of moles of acid equals number of moles of base. The mole ratio, we are going to see molarity of acids, volume of acid. Molarity of base equals volume of base equals the number of moles of acids divided by the number of moles of base. So this NAMB represents a stoichiometric coefficient. So the coefficient of the acids here is 1. Because there's no number. No number means it's 1. So the stoichiometric coefficient of the base is 2. What does that mean? See the means of MB is 2 from the balance equation. Na is 1 from the balance equation. Apply the formula. Molarity of acid, volume of acid divided by molarity of base, volume of base equals to 1 over 2. From here on, you can make molarity of acid subject to the formula or molarity of base subject to the formula. We're going to take an example. Taking an example in one such experiment. Low between molar 30 cm. Sodium hydroxide reacted with 10 cm. La liste of 12 tasks total. Calculate les molarity. Calculate the molarity of sulfuric acid. So, calculate the molarity of sulfuric acid. The first thing to do is to write a balance equation. The data have been limited on the equation. So let's make straight. Okay. So in this case, we are going to write the balance equation. The reaction is between sodium hydroxide and sulfuric acid. So we have sodium hydroxide. We have sulfuric acid, which will give sodium sulfate. Sodium sulfate in 2 water molecule. In case we apply the formula, we have to add volume of acid divided by molarity of base, volume of base equals to. In front of acid, there is y, the coefficient is 4. In front of base, there is 2, the coefficient is 2. In this case, the question is telling us calculate the molarity of sulfuric acid. In that case, now we are going to find the molarity of the acid from the stoichiometric balance equation. We make molarity of acid solid with the formula. The molarity of acid equals to Mb Vb over 2 Va. So here, in this case, we are going to mark Mb. So Mb is the molarity of base. In that case, is the root plus 2. Hence, the volume of the base T all over 2 times the volume of the acid. The volume of the acid is 10. Do cancel. Or like it's 0.1 over 0.2 over 2 is 0.1. So 0.1 times 3 could be 0.3 mole. Or that's acid 0.1. But let's say try 0.1. So also to be taken now, let's say example. Seen on an acid base of fish. In this case, we are going to take the reaction of the carbonate. Now, the carbonate, the reaction. Okay, example 2. Example 2. In example 2 now, we are going to actually do the reaction of the carbonate. Even though the reaction is still acid base energy. So I'm going to say is in one such experiment. In one such experiment, l'over est tout le monde. J'ai 40 cm pour cure de l'eau ici. Sodium carbonate reacted with 10 cm3. 10 cm3. Dilute. Je vois, c'est le temps de connaître. Chlorique glycérol. C'est tout le test comment c'est que les titres des gens. Qui aussi s'en trouve. Des molarity. Calculate the molarity on ACL. Calculate the molarity of ACL. The equation goes thus. In one such experiment, 0.2 molar 40 cm3 sodium carbonate reacted with 10 cm3 dihydrochloric acid. Calculate the molarity of hydrochloric acid. So once we calculate the molarity of hydrochloric acid, we are going to write the valence equation. The valence equation is sodium carbonate combined with acetylene. Sodium carbonate reacting with HCl. In this case, whenever a carbonate reacts with an acid, 3 main compounds will form: salt, water, and carbon dioxide. In that case, what we're going to have sodium chlorate plus water plus carbon dioxide. Both are balance actually. The number of sodium anomalies to the other side is just correct. I have to balance the number of sodium. So I'm going to put 2 here, balance. But by putting 2 there, what we realize, by putting 2 on sodium chloride, the equation is not balanced at all. Because the number of chlorine now becomes 2. We have to also put 2 here to balance chlorine.
By putting 2 there, the number of hydrogen is being affected also. We check the number of hydrogen, it is 2. Non-equation is balanced. Then we are going to apply the mole ratio. The mole ratio we are going to say molarity of acids, volume of acid divided by molarity of base, volume of base equals to Na, which is 2 for the acids, divided by 1, Na which is 1 for the base. 2 for the acid because the coefficient of the acid is 2, the coefficient of the base is 1. By so doing, what we're going to have, we're going to make molarity of acids. Sorry, the formula. We can't multiply. Molarity of acid equals to 2 ND V all of our acid molarity of acid equals 2 times 1 plus. Molarity of base, in this case, summing. So base, let's check the molarity of base. In one source, experiment. 0.2 molar, that means 0.3 molar times volume of the base. The volume of the base is 40. 40 divided by volume of the acids. The volume of the acids in this case is 10. In that case, look at molarity of acids equals to having 2 times 4 is 8. But 2 times 4 is 8. 8 times 3, that is 1.6 somewhere. That is acids. So go to the second part of titration. The second part of titration, we're going to talk about redox titration. The redox titration, we're going to see redox comes from the word redox, means reduction and oxidation. You will do to redox propulsion.
Yeah, you then on that hour.
The redox calculation. Mental. Redox nutrition. So in the redox titration, 2 things occur: reduction and oxidation. You can define a redox reaction as a reaction in which reduction and oxidation occurs simultaneously. Consider the redox equation below. We can have a redox reaction as FET plus the manganese O2 minus giving Fe3 plus Mn2 plus. In that case, now we want to talk about balance the redox equation. Use the redox equation now to determine either the molarity or the concentration or the number of moles of either of the fluids. The first thing to do is to balance the redox equations. So to balance the redox equation, we are going to identify which species is the oxidizing agent or which species is the resisting agent. By so doing, we follow up by calculating the oxidation states of the various elements in the compound. For iron, in this case of your oxidation principle, iron is +2. 1 plus 2 iron. For manganese, you want to calculate what manganese, obviously. Now, which manganese? Yeah. The manganese is X. Oxygen is X and it's 4. So minus 8 equals minus 3. X is my element with X. X is equals to plus so X is plus 7. Iron here is plus 3. The manganese here is close because I'm taking the charges. So the charge here is plus 2. So the oxidation state of iron is plus 2. The oxidation state for manganese is plus 7. I've just calculated plus 7 because manganese is X. Oxygen is minus 2 in all its compound. The extraction of the peroxide. So oxygen is minus 2 times 4, which is minus 8, equals to the charge of the compound. The charge here is negative, so it's equals to -1. So X equals to -1 plus 8. I make X subject to the formula. They have realized that iron is being oxidized. Oxidation means an increase in the oxidation number. Iron is oxidized from +2 to +3. So I can write the oxidation half equation. Iron 2 is oxidized to iron 3 plus 1 electron by being lost. Oxidation is an increase in the number of electrons, or the increase in the oxidation state, so such that 3 minus 2 is 1 electron. We come back to equation 1. The manganese now undergo a reduction reaction. The manganese is 7 reduced to 2, so that 7 minus 2 is 5. By so doing, we have the manganese ion Mn04 minus plus 5E minus, giving Mn2 plus equation 2. So these are oxidation reactions. So here this equation is oxidation. Why? Because iron move from iron 2 to iron 3. Manganese here is being reduced. Manganese is moving from 7 to 2. We define oxidation as the loss of electron, while reduction is the gain of electron. So I realize that my equation is some snooker. The number of electrons are not balanced, so I balance the number of electrons. And yet in that year, so having just 1 electron, so I multiply it and find. Here I have 5 electrons, I multiply it and the 1. I add up and add the equations. So equation 1 plus equation 2, and what you have 5 iron 2 plus manganese iron, giving 5 iron 2 plus the permanganate ion plus the permanganate ion. In this equation, they can ask you to balance the electron in an acidic medium. In an acidic medium, simply means that on the left you're having water, on the right you're having water, on the left you're having hydrogen ions. So let's balance this equation in an acidic medium. So in this case, we are going to balance the equation in an acidic medium. So let's balance the acidic medium. 105 iron 2 plus the manganese minus plus H plus, all not given 5 iron 2 plus the manganese iron thickness plus packet. So we realize that the number of water molecule, the number of oxygen here is 4. The number of oxygen here is just 1. But by putting 4 there, the number of hydrogen climbs to 8, because 4 times 3 is 8. So I have 8. From the balance equation, we can apply the molecular ratio just as we apply for an acid-base reaction. But in this case, we're not more going to use acid or base. We're going to use oxidant and reductant. The oxidized agent is reduced because the oxidized agent in this case is the manganese ion, which is plus 7, is reduced to plus 2. The reduced agent is oxidized. Ion plus 2 is reduced to is oxidized ion 3. So ion is the reduced agent, while manganese is the oxidized agent. What is the physical significance of that? Is the manganese ion that oxidized ion 2 to ion 3. Is the ion 2 ion that reduced ion and manganese 7 to manganese. So let's apply the formula in this case. We're going to say MOVO MR carbon equals, in front of oxidizing agent, there's 1. In front of reducing agent, there's pi. So that's our unknown ratio in case we're talking about a redox reaction. So let's make use of this redox reaction in order to calculate either the concentration of the buoy or either ion
or the manually standing. So let's take an example. So we have speed on lesson 6. Press it 6. Redox application. So let's take a typical example. So here's a sample GC equation. So it's similar to what came June 2020. June 2025 like GC and Massey. So you say in one such experiment, que you see it of potassium dichromate. Where it with and iron salts. Reacted with that iron salt. In one such experiment, 0.2 molar potassium to manganate reacted is 0.1 molar iron salt. Write the balance again then. Write the balance division. Write the balance division for the reaction. Write the balance equation and the reaction. Add to the balance equation and the reaction. Add to calculate this the volume on the iron soup. Calculate the volume with iron soup. So in this case, the first step is to write the balance equation. That's step 1. Write the balance equation. Step 2 now is to do calculate the volume of the iron soup. So let's start with the balance equation. The balance equation is going to take a very large space, so multiply this and do the solution for this equation. So let's see how it done. Well, quite similar with when below. So, and let's move our data. The molarity of dichromate test is 0.2 mol. Volume of the dichromate is it changes in molarity I literally did molarity of the iron is golden 1 gram result. So write the balance equation. The equation is on a commit plus the iron salts. Here we are going to have chromium equals plus iron 2. So we realize that iron is oxidized. Iron moves from plus to decrease. I told you guys earlier that oxidation is an increase in the oxidation number. So iron 2 is being oxidized, and what about the chromium? So here we are going to look for the oxidation state of chromium in the chromium. So within Cr2 O7 2 man RTX minus 14
equals minus. In this case, you are just seeing figures come. Chromium is x times 2 is 2x. How is it minus 2? How is minus 2 times 7? That is minus 14. Equals the charge of the compound. The charge of the compound binds to make x a solid in formula. So solve the linear equation. Sorry, 2x equals to minus 3. Because 2x equals to 7. X plus plus. In this case, y plus 6. Here y plus 3. We can peacefully write our redox type equation. We hear that the ion is oxidized. So ion is oxidized from plus 2 to plus 3. In that case, we have Fe2 plus. Oxidized Fe3 plus E minus. We call that equation 1. And the chromium now is being reduced from chromium 6 to chromium 3. So we have the chromate O72 minus plus Ke minus giving CrT plus. Equation 2. But the equation 2 has a very big problem. The number of chromium atoms are not balanced. You see, here we have 2 chromium atoms, and we have just single chromium atom. We balance the chromium atom, but balancing the chromium atom will affect the number of electrons. So here we're having multiply the equation by 2, multiply it by 2, and also multiply the number of electrons by 2. So, but by so doing, we realize that the number of chromium here is 2, the number of electrons is 6. Just balance the number of electrons now. So we multiply here by 6, multiply here like 1. After doing a multiplication, I get up. So add it up, I'm gonna have 6 iron. So plus. We commit to minus. Don't forget how I'm doing the balancing in an acidic medium. So the reaction taking place in an acidic medium. Given 6 iron. Within 6 iron. P plus 2 chromium. P plus water. So here you are. So we balance now the number of oxygen atoms. Here we have 7 oxygen atoms. To multiply is 7. So that 7 times 2 is 14. That's the number one. Number one was quite long, but not impossible. We succeeded to balance the equation. Then Roman 2 is telling us that, okay, given that you unbalance the equation, make use of the equation by calculating the volume of the ion source. Automatically, we are going to make use of the stoichiometric coefficient. So, making use of the stoichiometric coefficient, we say molarity of O, volume of O, all over NRO, VR, equals to MO all over VR. The oxidizing agent automatically is ion 2. The oxidizing agent, the oxidizing agent is a chromate. The oxidizing agent is reduced. That means reduced from plus 6 to plus 3. The reducing agent is oxidized. That's why the reducing agent is ion 2, because ion 2 is oxidized from plus 2 plus 3. So we'll replace our data. So we'll have molarity of the oxidizing agent, which is 0.2, volume of the oxidizing agent, which is 20, divided by molarity of the reducing 0.1 times volume of the reducing VR equals NO. In front of the oxidizing agent is 1, in front of the reducing agent is 6. We make VR, submit the formula. VR equals to 6 times 0.2 times 20, all that divided by 0.2. So here we have
0.1 over 0.2 is related with 2. VR equals to 6 times 2 times AC. Equals to 6 times 2, which is 12. 12 times 2 is 24. So this is one go. Yeah. That's what you to be using.
So we're now going to go to the third part of the lesson 3, which will be the last part, lesson 3. We're going to see precipitation titration. So whenever we're reacting a chloride, the formation, obviously there will be a formation of the precipitate. If the reaction is done with if the reaction is done with a nitric, in that case we are going to have the precipitate. If it's a chloride compound, the precipitate is the white precipitate. If it's a bromide compound, the precipitate is a pale yellow precipitate. Then if it's an iodide compound, the precipitate is
The yellow precipitate.
lesson 6. Now we're going to see precipitation titration.
Fish. Like
So in the precipitation titration, obviously we are going to have a reaction whereby a silver ion, Ag plus, react with the chloride ion to form AgCl, which is a precipitate. So in this case, our mole ratio will be molarity per silver, volume of silver divided by
molarities of Cl minus volume of Cl minus equals N sigma divided by N. Yeah, yes, on the
We're going to take a typical example here. We are going to see a small example. In an experiment, government soon 50 cm. 30 cm. So incorrect. React it with 20 cm also. 30 cm. Ceramic. Calculate the molarity. Calculate the molarity of silver liquid. So in this case, we are going to write a balance equation. Our equation is between the sodium chloride and silver nitrate. But remember, so we're having sodium chloride plus silver nitrate giving silver chloride or sodium nitrate. So after the formula, molarity of Ag plus volume of Ag plus divided by molarity of Cl minus volume of Cl divided equals to 1:1 cup. The stoichiometric coefficient is 1/1. So given that our coefficient is 1/1, so we make use with molarity of Ag. That's how the calculator. Molarity of Ag plus volume of Ag plus means in all over molarity is 0.2 times volume is C to 80 equals to 1/1. So molarity of Ag is equals to 0.21. So you cross multiply 20 cancel The molarity of AGC is equal to 2 So we arrive at the end of our topic, chapter 1. Chapter 1, which was the mole concept. Thank you for watching and follow more on Easy Peace.